to know from the business user, the end user, identify the pain points, what are the areas that they need help. So that's what we should be doing in the collaborate part. Then we define the business objectives, KPIs, analytical milestones, all those things we'll be defining. In collate, we do the data ranking and data, or the original features, we derive the new features, all those things will be done in the collate part. The feature extraction is done in that collate part. And building the model is simple mathematical equations. We using simple mathematical equations, we derive the model. And so deploy is basically to test the model in the production environment and capitalize the features, whatever the to make the model better is what we'll be doing in the capitalize.
I don't see Mithun in the.
Yeah, I think so. He left by mistake. I'll text him again and ask him.
He's not in campus.
Yeah, he's not in the meeting. I think so. Maybe network issue. I'll text him again.
Yes, please, guys.
Yes, sir.
You wanted to tell me something?
Nothing, sir.
Okay, fine.
Mithun, you are not in the Teams for last 5 minutes or so.
Yeah, yeah, Ganesh. Actually, network is down, so that's why.
No, I'm in Teams only. I'm talking to everybody. I felt I can see everybody and.
No, Mithun, you got dropped.
In the meeting. Actually.
Okay, for a second or something, I got dropped and I quickly sort of rejoined. But anyway,
we didn't hear you for last 2 minutes or so. So could you please repeat whatever you were saying?
Okay, fine. Fair enough. Fair enough. Okay, fine. So I was just saying that, we had a discussion about Project Fluid, the 6 steps. So can we just quickly recap about day 1 and day 2, a high level perspective, because some of the concepts about hypothesis testing and such things we'll be using in day 3, which is today. So that's the reason if you can get into a, sort of a discussion mode or a conversation mode now, I was just saying that, these terminologies that we are talking about will be less intimidating at a later stage. Right. So I was just encouraging all of you to talk. That's what I was just saying. Yes, please. Firstly, am I audible to everybody?
Yes, sir.
Yes. Am I in the call?
Yes, you are there.
Yes, yes. So let's just take this forward, guys. So after fluid, right? What are some of the steps that we saw? First day, if you remember, we spoke about descriptive statistics and such things, correct? We spoke about mean, median, mode, those sort of things. How do you sort of evaluate the sample size? Why is sample size important and such things? Then we spoke about the types of variable, right? We spoke about the types of variable. Anybody can think of the types of variable, guys? What are the different types of variable? Which do I use when? Fantastic. Okay. What is the difference exactly?
The word itself, numerical deals with numerical data only. Categorical deals with strings.
Slightly controversial because I can have gender, which is coded as 1 and 2. It is numerical, right? Right. So Python nomenclature is slightly confusing here. When we say numeric, I can have a variable like gender or marital status 0 and 1 I'll code. It becomes numeric, but it is not necessarily numeric in that sense. It would be categorical still. So fundamentally, if you look at it from a statistical perspective, when we are talking about variable types, there are 2 different types. One is what is called as a scale. Second one is what is called as a categorical variable. Therefore, I was very clear about the terminologies, right? I would rather use the word scale. Scale is any variable which has units, right? Variables which have units like distance can be expressed in kilometers, height can be expressed in feet, weight can be expressed in kgs. All these are examples of scalable variables, scale variables which have units, right? They have meaningful decimals, right? If I say my height is 6 feet 2 inches, 6.2, you would still be okay with that, right? 6.2, right? Distance is 5 kilometer, whatever, 200 meters, right? So decimals, meaningful decimals and such things are possible, right? Marital status, either if you look at marital status is either 0 or 1. Here we can't think of decimals. You can't have a value of 0.5, half married, half unmarried, right? Number of deaths in an accident, right? You can't have 2.5. There are 2.5 accidents that we took place. Does not make sense, right? We're talking about essentially whole numbers and such things. And more than that, basically, they have inbuilt categories, right? In the case of categorical variable, gender, marital status, job category, state, your caste, religion, country, all these things are nothing but categories. Categories, basically, we can at best break the data. We can compare, not more than that. Right, with categories, I can compare. With the scale variable, I can take average and such things, correct? We looked at a lot of charts and such things in the first day, like, pie chart we looked at, and then we looked at bar chart, box plot. All right. What else did we look at? Scatter plot, yes. Line graph. Anything else that we looked at? Mostly these, I think, right? Mostly these. Okay. Then in day 2, what did we do, guys? Day 2, what exactly did we do?
EDA, we started with the ADA, and again, we started with a description for the fluid part, and then to EDA, then inferential status.
Exactly, right. So mainly, if I remember correctly, we spoke about pandas profiling package, correct? How we can, we began by speaking about pandas profiling, how we can use pandas profiling to construct our own EDA. Within that EDA, we saw a lot of things, right? A lot of output it gives. It gives you missing values, it gives you sample size, it gives you duplicate cases. We spoke about correlation, two types of correlation. Do you recall what are the two different types of correlation, guys? Do you recall? Anybody?
Pearson's and PMN
Very good.
correlation.
Very good.
So
Yes, yes.
Pearson's for the actual whenever the actual data is given, and PMN's whenever the data is in case of rank.
Exactly. We saw a lot of graphs and such things like histogram, those sort of things we saw mainly when it comes to histogram, scatter plot, those sort of things we saw. Anything else that we saw this? Pearson's and Spearman's to just clarify that point. Yes, actual data. In the case of Pearson's, we have actual data. In the case of Spearman's rank correlation, we have rank data. Secondly, even when the sample size is very, very small and such things, you can again use Spearman's rank correlation. If the sample size is massive in terms of thousands and such things, you can use Pearson's correlation. If you see that there's a lot of noise in the data and such things, let's say you're doing a scatter plot, you see a lot of outliers, data is not normally distributed. Again, you can switch to Spearman's rank correlation rather than Pearson's correlation, right? After this, what did we do? This is about the EDA part of it. In session 1, we looked at EDA. Next, what did we do, guys?
Three one sample T test, A/B testing, and sample.
Exactly. One sample. We moved at how we moved towards hypothesis testing. Correct. Hypothesis testing. Why do we need hypothesis testing? Exactly.
To compare between two groups.
So that is the specific type of test, but fundamentally at a conceptual level, when we say hypothesis testing, what exactly is hypothesis testing? Why do I need hypothesis? Why do I need to spend my time doing hypothesis testing?
It is a part of our research to understand whether the claim is right or wrong.
Whether the claim is right or wrong, okay? Okay.
So there we look at relationships, correlation, and comparison.
Yes, 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 yes.
And when it is categorical values, we look at doing the relationship test. When it is numerical, we look at the correlation.
Fantastic.
And as part of the t-test and others, so when we look at doing the
right.
comparison between individuals or like between the groups.
Right. Guys, EDA is one part, right? Exploratory data analysis is one part. The next stage after EDA is basically to do hypothesis testing, right? Hypothesis testing. We do a lot of hypothesis testing because the business many times the clients have their own inbuilt hypothesis. Right, they have their own ideas which they want us to test. They want to find out whether statistically is there any evidence for them to believe that there are certain patterns which they thought existed. Do they still exist? Is it relevant for them to believe that if you're looking at store level data? I was working for Target some time back, so we used to get a lot of hypotheses saying that there is a service. I'm just giving giving a live example wherein I worked on hypothesis testing. They had in Target. Target is one of the retail outlets, and they have around 1,770 different stores in Target. 1,770 stores. Now, every now and then, they monitor customer satisfaction. Are the customers satisfied or dissatisfied? That is one of the questions. If customer satisfaction is low, obviously we have to improve it. If it is high, it's a good sign. So one thing that they would always, one of the constant sources of complaints is basically when we would look at the customer survey, customer rating and such things, they would sometimes feel disappointed. They would feel, the customers would feel disappointed that let's say they have gone to a Target store and picked up only 2 items. And for them to get the bill and walk out of the Target store, they have to spend 20 to 25 minutes because there's a long queue in front of them. Right, any customer would basically be disappointed. Boss, I've just picked up a dozen bananas and I have to stand for 15-20 minutes. They would rather drop and they would go to the nearby store. right? So they would constantly, ask this question. If you have 20, 25 items, it's one thing, but for 1 or 2 items, why should I spend 15, 20 minutes? And this is a big problem. The problem that I have expressed, the way I'm expressing, maybe it may look like a childish thing, but there it becomes very difficult. You know why? Because all the target prices are higher for any item. If you pick up in Target and compare it with Walmart, in Target, basically it will be way higher. The items are all more expensive than Walmart. Walmart, they pride themselves on cheaper items. Target, they price themselves on not on expensive items, but for the customer service. They say basically our service is fantastic. Stores are always hygienic. You can come here. Our staff members are very friendly. They deliver the high quality service. You can have a good experience here. And when that core value itself is shattered, then basically then the next question is, boss, I don't find any difference between you and Walmart. They're making me stand for half an hour. You're also making me stand for half an hour. Then why the hell am I paying more for you? Correct. That's the argument. So your core values, basically you try to protect, right? So this is where Target introduced, what is called a self-checkout. Self-checkout is basically a machine wherein for lesser than 3 items, if you have barely 2 or 3 items, you can automatically, you don't have to wait for the cashier. You don't have to stand in the queue. If I purchased a dozen bananas, there is a machine there. I'll just enter. This is the item that I purchased, and let's say $36 or $20. I myself can enter it, pay the money, and walk out. I don't have to stand. So this is not valid if you have a lot of items. Now you have introduced this service. Now what is the guarantee that the customer satisfaction is up after introducing this service? After self-checkout, the name of the service is self-checkout. You can automatically by yourself, don't need to stand on the queue. You can automatically walk out, check out, pay the money and check out for 1 item, 2 items, 3 items. You don't have to spend 15, 20 minutes. Now they can't roll out this service in 1,770 stores and then realize, oh, we have made a big mistake. So what they do is basically they do what is called as a control test study. What is this control test? Before rolling out across 1,770 stores in Target, and I know this because we used to do extensively this kind of work. What they do is basically they pick up 30, 40 stores randomly. They put up self-checkout, this thing, self-checkout services, right? For the remaining, they don't put, right? Now, as statisticians, we have to basically tell them, as analysts, we have to tell them, basically after self-checkout, has the customer satisfaction gone up or down? If there is strong and solid evidence that after putting up self-checkout services, customer satisfaction and such things have gone up. The average queue time that a person spends in the queue is reduced in self-checkout vis-a-vis a store wherein there is no self-checkout, then basically it's a good sign. We don't mind implementing it from 30 to the next 40. After that, another 40 services, so that in all Target stores, we have self-checkout service. But even if I have to spend money in putting this self-checkout services for 1,770 stores in Target, it's a big spending that I'm doing. So I would like to go to the top management with strong statistical evidence saying that, boss, after putting up this self-checkout services, customer satisfaction has gone up. Customer satisfaction has gone up. The number of negative comments and such things have come down. The average the average time that a customer spends in the queue has come down. So this is where your A/B testing, control test and such things comes into picture. This is a hypothesis that they have, that after putting up the self-checkout services, customer satisfaction and such things will go up. Statistically, is there any evidence? Right? The source of discontent may not be self-checkout. For all you know, it could be something else. There could be other things that persons are people are not happy about, right? But after putting this up in 40 stores, if you come to the conclusion that there is no difference at all in the customer satisfaction between those stores wherein there is self-checkout and those stores where there is self-checkout, if there is no difference at all, then why should I waste my money? Why should I spend my money in self-checkout services? I would not rather implement it for all 1,770 stores. So these are all problems. So this is a hypothesis which we wanted to test, and to do this hypothesis testing, what did we do? A/B testing, right? 2 groups, right? We also spoke about benchmark analysis, 3 types of comparisons, correct? You can compare your child with neighbor's child. If you're comparing your child with neighbor's child, that is two groups. Remember, control group versus test group. That is a case of A/B testing. A group versus B group. Two different variants. Right? Digital marketing and such things extensively used A/B testing. Then the second is what? Benchmark analysis. Benchmark analysis is what? The class average is 60%. You want to check whether your student is getting 60%, less than 60%, or significantly greater than 60%. The industry average for IT professionals when it comes to salary is 60,000. I'm just giving an example. 60,000. I want to find out whether my company is on par with the industry standard, or am I underpaying my employees, or am I overpaying my employees? The churn rate, people who leave the company, is, let's say, 6%. I want to check whether in my company the churn rate in the last quarter is 6%, less than 6%, or greater than 6%. If I'm 6% or close to 6%, it means basically that I am doing as well as my industry is doing, not good, not worse. If it is less, it's a good sign, because fewer people are leaving my organization. There are fewer people are exiting my organization. If it is higher, which means that basically my company, there is more attrition, people are leaving, which is a problem. I need to take corrective measures. Right? So this is all benchmark analysis, A/B testing, benchmark analysis. Third is what? Before and after, we said. Before and after is what? Before training and after training, is there a difference? Before breakfast and after breakfast, is there a change in the blood sugar level? Right? Before, mainly in call centers and such things, you see when they hire new employees, the calls and such things are not routed to the right person. Right? If I'm making a call because I'm experiencing some bank issue and the person does not even know how to answer the questions that I'm asking. If you don't know, it's one thing. At least route my call to the right person so that he can get answer. He's not able to do anything. What happens? Customer dissatisfaction goes up, satisfaction levels go down. What do they do basically? These 10 or 15 people, they give extensive training. They should be very, very well trained to address customer queries. This is the query, this is the answer. This is the query, this is the answer. A is the query, this is the answer. X is the query, this is the answer. Something else is the query, something else is the answer. So they should be very, very well versed in these things. Right? So before the training and after the training, right? What is the overall dissatisfaction? Has it come down or not? If it has come down, training is effective. If it has not come down, right? If it has come down, training is effective. If it has not come down, training is ineffective. So all these things are part of what we call as hypothesis testing. So far, are we clear, guys? Everybody? This is all part of hypothesis testing.
So one question that I have, Mithun.
Yes.
So in hypothesis testing, do we say such and such a thing is true, or do we say such and such thing is false? And then take the alternate hypothesis as the opposite one. So what is the industry standard is?
No, can you come again? I am not very clear with your question.
Okay, in hypothesis testing.
Yes.
So there is a null hypothesis.
Yes, you're right.
So our null hypothesis should be written in a negative way or in a positive way?
Good question. Very good question. Let me clarify this point, right? Null, N-U-L-L, right? We null hypothesis we say is dull hypothesis, D-U-L-L. Null is dull, we say. Why? Because null hypothesis is the hypothesis of no change. No change. By definition, when you are fixing the null hypothesis is the hypothesis of no change. There's a change. It's a hypothesis wherein there is no difference, no relation. All these things, when I'm saying no relationship, no association, no difference, all these things will be part of my null hypothesis. Alternative hypothesis is always exciting. Why? Because what if the null hypothesis is that, I'm just giving an example in the context of weights. There is no change, no within double quotes. There is no change in the weights of the patients before taking medicine and after taking medicine, right? No change, right? Alternative is what? There is a change. There is a change. There is a change that is always exciting, which means that there must be something in the drug which is working, right? Now, alternative hypothesis is always more exciting than null hypothesis. And secondly, as a researcher, though I have not explicitly stated anywhere, no researcher ever explicitly states this. When you're a researcher, when you put yourself in the shoes of a data scientist or a researcher, what do you say? One of the first and the primary quality of a researcher is that he should be unbiased. He should not be prejudiced, right? I may be an Indian, right? I may want Indian cricket team to win. But if I am actually comparing the performance between India and Australia, if I'm a researcher, what should I say? Last 10 matches, how many matches has India done well? How many matches has Australia done well? In India, what is our, do we have top 5 batsmen who are better than Australia or vice versa, whatever be the case, correct? A good researcher does not bring his emotions, prejudice and such things into picture. We are not going by preconceived notions, correct? This is what is the quality of a good researcher, correct? A good researcher does not care whether he accepts null hypothesis or rejects null hypothesis. But if you actually look at the back of my mind, though I am not explicitly stating anywhere, I as a researcher want to kill my null hypothesis. I want to reject my null hypothesis. I'm not stating this anywhere, but when you are a data scientist, when you are a researcher, when you are into AI and such things, you should always try to reject your null hypothesis. Not try, but you should be excited about rejecting null hypothesis, because null hypothesis, if you go by the null hypothesis, you are killing your own research. If there is no change, it's full stop. There is no change. There is no change. You can't do any further research. On the other hand, if you reject your null hypothesis, I will go by my alternative. Alternative means there is difference. Then there is a more scope for research. If I go by alternative, there is more scope for research. So as a researcher, I don't want to kill my own research. I want to do more and more research. So going by accepting the alternative facilitates further research. That is the reason as to why we are more comfortable rejecting the null hypothesis rather than accepting the null hypothesis, though we don't explicitly state this anywhere, though we don't write this anywhere. But as a researcher, I want to reject the null hypothesis. Specifically to your question, remember, null hypothesis is the hypothesis of no change, no difference, no relationship, no association. Null is dull. What is usually dull? What is the hypothesis of sameness, the hypothesis of constancy? That is part of your null hypothesis. Does that answer your question?
Very, very nice, Mithun. Thanks so much. So, when it is false, rather than just saying that null hypothesis is false or saying alternate hypothesis is true,
Yes.
so why does we complicate by saying that we fail to reject? Because we are using two negative words there.
Good,
So that
very
is
good
kind of a
question.
twist.
It's a brilliant question which you are asking me. It's a fantastic question that you are asking me. I use the word accept, right? It is not the correct language to use. The word accept is not used in any good statistical textbook. They laugh. They would rather laugh at me. They would make fun of me saying this fellow is not a statistician because he's using the word accept. We don't use the word accept. How can you accept something? We can't. So when we are coming to the inference or conclusion, when we are making any inference or conclusion, you know what is the language, the vocabulary of a scientist or the vocabulary of a statistician or the vocabulary of a researcher. We say this is more or less the language. The words could be slightly here and there. The words and the vocabulary will be something like this. Since the p-value is less than 0.05, there is no sufficient evidence for us to reject null hypothesis, and therefore we fail to reject null hypothesis, right? There is no sufficient evidence that we say what null hypothesis may be true, but when I look at this in the data, there is no sufficient evidence. Therefore, we fail to reject null hypothesis. When we say fail to reject, it's almost like, I am crying. I am sad that I am not able to reject my null hypothesis. But what do I do? The evidence is not there. So therefore, because of lack of evidence in the data, I am saying that there is no sufficient evidence, and therefore I fail to reject my null hypothesis, fail to reject. So rejection is given more importance because as a researcher, I would rather reject rather than accept. And secondly, I'm just giving an analogy here, right? If you have a lawyer as your relative, right? You have anybody in the field of law and such things, you ask them what is the fundamental principle of law or any legal tenet. One of the fundamental ideas, at least in a democracy, is that you're innocent till such time as you're proven guilty. A person is presumed to be innocent till such time as there is strong and incriminating evidence. There should be strong. A person may be a murderer, right? But the benefit of the doubt goes to a murderer himself unless whatever the police, everybody are able to find strong incriminating evidence. The basic idea behind this is what? That not one single innocent person should be hanged. 1,000 guilty men can go scot-free, but not one single innocent man should be hung. He should get punished. The same way here, we are borrowing more or less the same principle here. Unless there is strong and incriminating evidence for me to reject my null hypothesis, I will not reject my null hypothesis. I would rather put the onus on you saying this is not sufficient, boss. This is not sufficient. There is no sufficient evidence. By default, the null hypothesis is assumed to be true. Right? We are status quoist. Status quoist means what? There is no difference between male salary and female salary. There is no difference. That is the status quo. I am not differentiating. If there is a difference, when can there be a difference? There is strong and incriminating evidence in the data. We have found out very, very strong, compelling evidence for us to believe that null hypothesis is false. Only then we go ahead and say, boss, there is a lot of evidence in the data. At least 95% evidence is there in the data that there is a relationship between male salary and female salary. Then you'll be thinking, oh, why is it that gender influences? Is it true for one company? Is it true for all the companies? Is it true only in Bangalore? Is it true for all the metropolitan cities and such things? So as a researcher, I want to reject my null hypothesis. But textbook and such things say by default, unless you have compelling evidence, do not reject null hypothesis. By default, null hypothesis is presumed to be true. It is presumed to be true. Right? An innocent person should not go to jail. The same way, null hypothesis is always presumed to be true. It is status quoist. Between men and women, I am not differentiating. I'm not differentiating. Right? If there is a difference, what will be my counter argument to you? Let's say you found out, let's say I'm just giving an example. Let's say Mr. Ganesh has come back to me while doing some analysis. I'm just giving the example of Ganesh since Ganesh asked me this question. And he says, sir, based on the box plot, I see that male salary is higher than female salary. You know, what will I say? I'll say by some accident of fate, it has happened. It is because you're taking a bad sample, this has happened. You have taken a bad sample. Take another sample, you may see a different pattern. This is my counter argument. Right now, the onus I'm putting on Ganesh to come back with strong and incriminating evidence for him to say, sir, box plot said this. Also, there is strong statistical evidence that even if I change my data set 100 times, at least 95 out of 100 times, male salary will be bigger than that of female salary. It is for Ganesh to come and tell me this. Right? And for this, what will Ganesh do? He will frame the null hypothesis. He will frame the alternative hypothesis. He will frame all this 5% margin of uncertainty. 5% means what? 5 out of 100 times because of bad sample or some accident of fate. Mr. Mithun, what you're saying is correct. 5 out of 100 times. But 95 out of 100 times, I'm sure that my box plot is telling you a pattern. That pattern is that the male salary is less than female salary. 95 out of 100 times. That power, that statistical power comes from p-value or probability value. Why am I comparing it with 0.05? What is that 5? If I repeat it 100 times, 5 times through some accident of fate, I've got a bad sample. Maybe the data collection is faulty. Something has happened, and therefore I'm getting a bad result in the box plot. Right? But I can't argue the same way when I look at the p-value. When you look at the p-value, what does that say? The p-value basically says, boss, if you keep repeating the experiment 100 times on 100 different samples, right? Make a mess of the sample, right? Shuffle it, take a random sample, 25% here, whatever it is. If you repeat this 100 times, at least 95 out of 100 times, at least 95 out of 100 times, what do we see? We see that there is statistical evidence for us to say that male salary is less than female salary. I'm not saying that, right? I'm not 100% sure. I'm saying that there is statistical evidence for me to say that male salary is higher as compared to female salary. Statistical evidence, I'm saying, right? 5% of the times I could be wrong. 95% of the times I am confident because of statistical evidence. So I'm very, very apprehensive. I'm very, very careful about binaries. You know, it is 100% true that male salary will be greater than female salary, or I'm 100% sure that female salary will be more. I'm not making in those extreme positions. I'm saying, boss, there is statistical evidence for me to believe that there is a difference in the salary between males and females. How confident are you? At least 95 out of 100 times, there is a chance that male salary will come out to be greater as compared to female salary. 5 times I can be wrong because I'm not a god. I'm an analyst at the end of the day. Right? With this, the question of bad sample, that is a bad sample you have taken. Accidentally, it has happened. Those things do not come into picture when you're doing hypothesis testing. Those things come into picture when you just look at a graph. Looking at a graph, you can say, boss, you've taken a bad sample, therefore the same thing is getting reflected. In 2016, right, you can just look at this. Campaign analytics and such things happen in United States of America, right? Donald Trump was facing off with Hillary Clinton. Stanford University professors did campaign analytics to study between Donald Trump and Hillary Clinton. And you know what they said? We are 90s, above 95%, they said we are sure Hillary Clinton will win the 2016 election. Hillary Clinton, what happened? On the day of election, basically exactly opposite happened. You know, Donald Trump went on to win the election. You know why? Because many times the data is so complex that we can't be 100% sure about what we say. And in the US campaign elections and such things, you know, the biggest mistake that they make is they basically take a sample which is very, very paltry. You know how much they say? They take around 1,000 people or something. 1,000 or 100, I'm getting confused with the number, one of these two numbers. They take just 1,000 people and come to the conclusion that this person will win or lose. How crazy is it that, you know, large country like United States of America, you're studying 1,000 people and saying that basically exit polls suggest that Donald Trump will win, Obama will lose, X will win, he will lose. Therefore, whatever happens in the exit polls and such things, you should take with a pinch of salt, because the sample size that they have studied itself is very low. Their hypothesis testing, everything may be perfect, but the sample size and such things, how are you taking that into account? So you can never be sure. Is this concept clear, guys? Hypothesis, why are we using the word, right? We fail to reject. I'll never say I'll accept my null hypothesis, right? I fail to reject my null hypothesis because the data is not saying this. Or I'll say I'll reject my null hypothesis, which is a big, big smile. I'm very happy to reject my null hypothesis because I will get an opportunity to do more analysis, more research, right? So at the back of my mind as a researcher, I want to do more research. When can I do research? Only when you reject your null hypothesis, not when you go by your null hypothesis. So usually, right, we say use a double negative or a triple negative. Fail, the word fail is a negative. Reject is negative. So we at least use two negative words in the inferential part. We reject or we fail to reject. There is no statistical evidence, therefore we fail to reject. This is the way in which we couch our words, because we are not gods. We are not basically priests. We can say, you better believe that this is true. We are saying we have done analysis in the data. There is no sufficient pattern, and therefore I fail to reject my null hypothesis. Right? What is the evidence? There is 95% chance, at least 95% chance that I'm confident that this is the pattern in the data set, and that same pattern will hold good if you take a real life data set as well. If you do this experiment on a real time, 5 times I can go wrong. That's possible.
Sure, Mithun. Kind of coming to terms.
Yes, yes.
Only thing
It
is, like,
happened.
during the quiz, if it is time bound, uh, I think I will lose. Yeah, need some more example for me to go through it. One related question that I have, uh, what happens next? You, you do the hypothesis testing and then you conclude certain things. So what happens next?
Yes. So business decisions are made based on this. Now I'll just give the example of this target and self checkout thing, correct? So we basically found out that after using self checkout, there was a slight bit of an increase in the satisfaction score given by people for those stores as compared to other stores. Correct. We not just satisfaction score. There are in the field of marketing, there are multiple metrics. One is customer satisfaction, which is called a CSS, customer satisfaction survey or customer satisfaction rating. Second one is what is called as OSAT, that is also tracked, organization satisfaction. Third metric that they track is NPS. NPS stands for Net Promoter Score. NPS stands for Net Promoter Score. We checked on various metrics. We made a comparative study between those stores wherein we have self-checkout and those stores where we did not have self-checkout. At least 10 different metrics we compared between stores wherein Target had implemented self-checkout and those stores wherein we did not have wherein we did not have self-checkout. By and large, for most of the metrics, right? The satisfaction level, net promoter score were always higher, slightly higher as compared to those stores where self-checkout were not utilized. So this is what we communicated to our client as well, to our business partners as well, saying that, boss, after implementing self-checkout, we have seen a positive change in customer satisfaction, net promoter score, reduction in time, also the traffic basically, right? And therefore, there is evidence for us to believe that self-checkout and implementation of self-checkout is a good thing. And therefore, we recommended as a next pilot, you can roll out this self-checkout for few other stores as well. Right, out of 1,770 as a pilot, they had done it for 40. We basically make it a recommendation from 40, please increase it to another 30, 35, you can increase it. We can't do it 1,770. We can't do it just like that, right? In one shot, we can't do. From 40, let us take incremental steps, 70, right? Will be next step is 70, then 100. If we continuously see the benefit of using self-checkout, then it makes sense for us to carry out this program for the entire organization, right? This is in the case of Target. Now, if you look at this drug response and such things, correct? Between the test group and the control group. We spoke about this last week, correct? Test group receives the drug. Control group does not receive the drug. So for a drug to come out in the market, they do a lot of this statistical analysis and such things, and they're supposed to report their findings and say, sir, after doing multiple levels of test, there is strong evidence for us to believe that the new drug, streptokinase, outperforms the old drug altiplase and retiplase. The length of recovery from the disease is shorter, the treatment costs and such things are shorter, and therefore the new drug is more effective. If the new drug is statistically found to be more effective, then you can basically sell it to all the pharmacists and such things. If the new drug itself is substandard and it is not at all yielding results as compared to the old drug, then why at all are we, why do we want to roll this out across to the general public? Or if there is no change at all between the new drug and the old drug, by and large, the patient recovery time, treatment cost is the same, then I might as well go with the older drug itself. I'll not spend money on the marketing campaign at all. Marketing campaign and all, when they say basically, ideally speaking, sometimes there's a lot of bluff, right? You do this and very quickly you see a turnaround. But usually if you do statistical analysis and such things, and pharmacists, all these people are expected to produce these numbers. I had a friend who was working in Novartis. Her job inside out, day in and day out, was to basically compare drug effectiveness and such things. And I should not be saying this. Many times they would say basically that 8 or 10 years they would struggle. They would come up with a new drug. But when they would take live data and compare the performance between new drug takers and the old drug takers, there would barely be any difference. So higher authority people who put a lot of pressure say, show a difference. Because we have spent so much of money for the last 8 years. If your statistical analysis says that there is no difference, then I'll not be able to roll it out to the market. So she used to literally be in tears. She used to say was literally we manipulate the data many times. So to show that the new drug is actually outperforming old drug. Otherwise, this will I'll lose my job. Right. So if any treatment, right? So the same thing with the layout, your, any company layout, right? The design of the layout, digital marketing and such things, traffic inflow, how many people are getting, how many people are coming to the landing page, how many signups are there, how many people are vacating, they come and then they don't do much, they just leave. Right, e-commerce websites and all, their front page, welcome page or the landing page is very, very important. How many subscribers are there? So there are a whole lot of metrics, and from time to time they keep changing the design, layout and such things. If they feel that the traffic, customers who are converting, customers who are subscribing, customers who are paying a visit, if that is not good, what do? If there is no difference at all between the new layout and the old layout, then it's a waste of time changing all these things, isn't it? Unless there is a appreciable level of change, that is in terms of click per views and such things, they will not, take the changes and all are, not meaningful at all. So may it be drug testing, may it be comparing between 2 groups or 3 groups and such things. The reason why we do this is because we can go back and say, yes, was after doing a self checkout, we have seen that customer satisfaction, and these are the 3 metrics: CSS, NPS, Net Promoter Score, and what is called as OSAT, Organizational Satisfaction Score. Correct? Within NPS also, it's a metric between 1 and 10. 1 and 10, correct? So between 1 and 10, let's say Pranesh has given a rating of 6 to me. It means that he's a detractor. 6 less than 7, right? It's a detractor. You have given 7 or somewhere around 7. So you're a passive customer. And he has given 9. Third person has given me 9. He is a promoter. So within NPS also, there are 3 groups: passives, promoters, and detractors. Now, I want to see basically whether the number of passives have converted to what? Promoters, right? If the number of detractors go up drastically, it means that all my NPS score and such things will come down. I don't want that to happen. So it's a case of comparing 3 groups and such things. If you want to compare 3 groups, we'll be using a test which is called as one-way analysis of variance. 2 groups, we do A/B testing. Right? So our this thing to come back to this question, he said basically after hypothesis testing what? So that's why he just answered this question. After hypothesis, we take certain decisions saying, boss, after implementing self-checkout, we have observed that in these 40 stores, the average customer satisfaction, the average number of promoters, the average OSAT score, by and large, they tend to be on the higher side as compared to those stores wherein you have not implemented self-checkout. So our recommendation to you is you can go ahead and implement this in phase 2 to other stores. You can just implement self-checkout. It's basically a machine and such things, right? You have to spend some money, right? You can't just roll it out to all. So if we say, boss, there is no statistical evidence at all, whether you put a self-checkout or not, customer satisfaction was not reduced at all, why would they take the time or the money to sort of, increase from 40 stores to 60? Nobody will do that. So they're looking for statistical evidence. You're the data scientist. You have to come back to them saying that we have seen evidence in the data that there is an increase in these 3 metrics. How will you do that? Show a box plot. After that, you do some hypothesis testing. That should be good enough. Is that okay, Ganesh?
Thank you. Very detailed explanation. Thank you so much, Mithun.
Thanks. Does it make sense, guys? Okay, guys, EDA is done. This is done, right? Now, I actually came with the intention of showing a small case study, right? So that you get a perspective.
Is there any screen sharing, Mithun, you're doing?
I'm not sharing anything as of now. I'm not sharing anything, right? At a very high level, right? What I would encourage you to do is, since you're beginning this, right? Develop what is called as a mini project. a mini project where there is less pressure on you. You know Kaggle, right? Everybody knows Kaggle, right? Kaggle you can go, or UCI machine learning repository. UCI machine learning repository, wherein you have e-commerce, banking, IT sector, cyber security, blah, blah, blah. There are 101 domains. For this, they'll give you free data sets. Whatever appeals to you, take a data set and start playing with some of these things. Start doing a simple independent sample status, or start doing a box plot, start doing an ANOVA, just try to trim off the outliers, right? Do a correlation matrix. Simple EDA is what I would like you to encourage, at least in 5 areas. Pick up banking. Pick up, one is banking, second one is customer analytics, CSS, right? We can come to image processing and such things later, right? In fact, that will be a lot easier because it's just once you learn, once you clean the data, push it in, you'll get the predictions, right? But this, at least the EDA part of it, right? Insurance, banking, you try once, try something in telecom sector. Try something in telecom. Try one in marketing. Marketing because it is universal by and large. And fifth one is basically any specific area you try. And try to develop a project. It's a mini project. Mini project so that you can develop your own confidence. Tomorrow, if you get an interview offer suddenly in telecom, right? You might not have any experience working in telecom. Correct? He will be asking telecom related questions. You are not from telecom, so it will be a complete mix match. Correct? But if you have developed these mini projects, and I'll tell this to every batch, not many people do it. Then at the end, basically they get, sir, he's asking some question. He's asking about CLTV. What is CLTV, sir? That confidence will come to you if you have worked on this, right? It need not be right. It need not be 100% right. At least get started with this, right? So that if the other person is telecom, or tomorrow you may meet somebody from banking. In banking, basically, I can't talk about recommendation engine. Right, if I'm going to Amazon or Flipkart, wherein if I talk about how I've implemented a recommendation engine, what's the cold start problem, what's the long tail problem, if I tell, they will be able to appreciate because that is specific to their domain, right? So if you are going to a specific domain and you do not know their lingo, their language, their vocabulary, you may be an expert in many algorithms, but you'll always cut a sorry figure. So this mini project, which I'm asking you to do, will build up your confidence in each of these areas. And at least you'll understand, OK, banking, what do they do? Credit risk analysis, they'll do. They'll do fraud detection. NPA, non-performing assets, basically, they will do all these things. If you're talking about telecommunication, CLTV, customer lifetime value. If it is B2B, BLTV, bank, business lifetime value. That is what they find out. You can, right? Who is going to churn? Who is going to migrate from idea to something else, some other service? You can speak that language. So for that language, you need to be sort of well versed with a few mini projects. Simple projects, not hi-fi or sophisticated. Right? Can I just take 10 minutes to give you a high level perspective about one small project so that you get an idea of what we have done? It's not part of your syllabus, but just to give you an idea as to what can be done. This is one of my projects. OK, let me just quickly share this. Right, just to give you an idea as to how you should actually, present your EDA, right? Can you see this, everybody?
Yes, sir.
Are you able to see this? Right? And don't take it very seriously, just understand, right? OK. So predicting crime using data analytics, right? Somebody gives a data set. In the interview, when somebody suddenly gives a data set, my brain will get jammed. Correct? Because I've never solved data, right? But if I do 10, 15 things, 10, 15 small ideas, it could be a simple A/B testing or a simple pie chart itself. Don't worry, get started, right? And 2017, there was in Kerala, in the state of Kerala, I think Thiruvananthapuram, there was a knowledge research conducted by Police Academy, wherein people from all over the country were called upon because they wanted to apprehend crime. The DSP of Palakkad had come and they were actually saying how they had used analytics to apprehend an incident of murder of a woman. They pulled out the call detail records, CDR, call data records. They pulled out, and based on data analysis, they were able to apprehend who murdered a lady. So we are thinking that usually when we think of police officers, what do we think? We see, okay, he's wearing khaki, he has a stick to beat with, right? Everybody is desperate for bribe. That's what we think. But some of the most intelligent and brilliant people were there actually. There's one more person. She's from Maharashtra. Her name is Pragya Sarwar. Right, very high level position she's holding, and she basically was saying, in my control room, I'm using GIS maps and such things to track at each police station how many jeeps, how many police officers, how many dogs, what is the level of ammunition that is being deployed. And if there is a level increase in level of crime and such things, basically we ask the nearby police station to monitor them. That is the level of analysis that police officers are doing. Right? I understand that your life and my life does not revolve around catching crime, right? But just to get some perspective about EDA, exploratory data analysis, look at this time and location profile on Kaggle data, right? Kaggle, you can go here, you can just pick up this data just to give you a perspective. When I look at the data, this is how the data was. Okay, guys online, can you see the data? Smaller.
Yes.
We are seeing your PPT.
Yeah, PPT is visible, sir.
What is it saying?
We are seeing your PPT, but it has the current slide and the next slide.
Okay, that's okay, not a problem. You can see the left side. Or is there a way in which I can show present only one slide?
Display settings,
Some options.
Display settings.
duplicate slide.
Now is it better?
Yeah.
It's better?
Yeah, this is good.
Yes, sir.
Let's take a look at this, right? What do you see in this data? This is called the San Francisco crime classification, okay? San Francisco crime classification. We have the date variable, date in which the crime was committed. Second one is basically category of crime, like warrants, other offenses, so on and so forth. Description of crime, day of the week, in which day was the crime committed. PD district is police district, right? Resolution of the crime. How did they sort of resolve? Did they arrest him? Did they not arrest him? What did they do? In which address was the crime, this thing committed, and lat long they have given, correct? So this is a data set. What can be done? This is a data set. Did you understand the data set? Very simple data set, right? So what can be done with this data set?
Can categorize,
Why am I showing this? Yes.
can categorize the kind of threats, like they are going to murder someone, that will be level 1.
Yes.
If they are doing a petty theft,
Risk category. Risk category based on risk category, high incidence murder and low incidence. Remember in the first day we spoke about scale variable, categorical variable. What is a categorical variable? Here, connected to whatever discussion we are having. Categorical variable. Are there categories in this data set? Yes, the category of crime is nothing but the categorical. Right? When this data set was given, one thing that I would like to suggest to you and really impress upon you, right? Forget all these algorithms for a moment. There are in the next 1 or 2 years, you'll learn a lot of algorithms. Convolutional neural network, you'll learn. Restricted Boltzmann's machines, you'll learn. Right? Auto encoders, you'll learn. PCA, you'll learn. T-SNE, you'll learn. All high fundo concepts you'll learn. It's good to know these things, and you'll also feel cool and intelligent. But the first thing is not the algorithm. When I come and give you a data set, first thing, any data set, what you should do is basically ask a simple question when you're a data scientist. Does this data set tell me a story? Algorithms come later. Algorithms really come later. It is like if a patient comes to me, sir, he says, sir, I have a bit of headache and I have a bit of temperature. I can't say, okay, fine, sit down. I'll just do a chemotherapy of 4 days. Can I say that? That chemotherapy thing comes really, really later, right? Isn't it? The same way here, usually when a person begins a conversation with something so far-fetched, right? He's not able to understand the problem, right? So when somebody gives a data set, does this data set tell me a story? Can I pick up certain useful insights which are otherwise not apparent to the naked eye? So this data set is what? It is just a fact table. It is lifeless. It is bloody dead. It is dead like a cold fish. Does it tell me anything? It is just a set of facts and figures. Someday, whatever, right? 13th May 2015, 11:53, somebody committed some murder or whatever it is. It was booked. It does not tell me much. My job, your job as data scientists is basically not algorithms. That has a place later. Can you pick up some story? This is the first job of a data scientist. To do this, right? done is this, right? See, take a look at this. I've got time. Can you see a time here, everybody? The first column, you can see here the time in which the crime was committed. I've taken crime and I've just plotted in the x-axis, 1 up to 24. Can you see here? There are 24 hours in a day. And in the y-axis, you know, what am I doing? The number of incidents. Correct? Number of incidents is what? A scale variable. Do you understand? And these 24 hours in a day, they are my categories. First category. Secondly, this arson, which is a kind of category, that is also a categorical variable. Please connect it to the discussion. Scale variable is y-axis. X-axis is categorical variable. Arson means basically in the West, basically people put their own items on fire. Insurance and such things are a big thing. So they put their own items on fire and say basically, sir, give me insurance money because my items are all burnt out now. So does this tell you a story? What does this tell you? If you look at this morning 4:30 or 5 o'clock, maximum number of arson related incidents take place. Can I say that? Right now, rest of the day in the afternoon, by and large, it is less. Again, we see a peak around 9 o'clock. It just takes off. Correct. Let me look at another set of data. Disorderly conduct I'm plotting. What do you see? What do you see here? Morning 5:30 or 6, the amount of disorderly conduct goes up. Correct. I don't know whether people are coming out from a bar or a pub, whatever it is. They're having a nice party and they're doing this 5:30 or 6 o'clock. Yes, please. No, this is not the case. Maybe you could just. Okay, the profile itself is different. Now just take a look at extortion, right? Does this now tell you a story? You look at this data set is dead, correct? It didn't tell me much, but simple EDA and such things, simple EDA, right? Look at this. This is basically disorderly conduct 5:30, extortion and such things in the afternoon it's happening, correct? So this is good EDA because I'm able to understand something from the data set. It is not about drawing a pie chart. What does that pie chart tell you? How is it useful to the business? If that you're able to tell convincingly in the capstone project and your assignments, hats off to you. Correct. Let's just show this. Drugs and narcotic. See here, basically around 5 o'clock it peaks up. In fact, from 2 o'clock all the way up to around 6 o'clock, it is very, very high. Do you agree? Right. Now, I again say the same thing. You and I are not police officers, but if we give this to a police officer, he now knows when to deploy his resources. We all have shortage of resources in India. Basically, if you look at the number of police officers to citizens ratio, it is 1:1,000. For 1,000 citizens, we have one police officer. Is it practically possible to manage? So since that we have shortage of resources and such things, how do you optimize it? This is a simple way in which you optimize. If you are bothered about drugs and narcotic related stuff from 2 o'clock onwards, all the way up to 6:37, you'll have to worry about deploying these officers. They work in shifts. Which time should you sort of which time? Is it morning shift or is it afternoon shift or in the evening shift? Should you deploy your officers? That is what we can plan based on this. Look at robbery, completely different profile. Right? Understandably, after around 10 o'clock onwards, it just picks up. Look at gambling. Look at the graphs itself. This graph is the earlier graph. Now this is the new graph. Gambling and such things happen in United States of America. This is in San Francisco. Live data this is. This is not cooked up data. Right? So this is happening when in the afternoon it's happening. Gambling. Correct? Suicide. It's happening at 8 o'clock. Right? When we have Ekta Kapoor serials. Right? All these Saas Bahu kind of serials. Right? Mother-in-law, father-in-law. Right? Gender-related offenses. Right? By and large, it's happening everywhere. But morning 1 o'clock in San Francisco, there's a peak. Right? Non-forcible offenses. Right? In the morning as well as in the afternoon, there is a peak. Forcible and or non-forcible offenses, correct? Now, this is about the time, right? Now, look at where is it happening? When is it happening? I answered. Where is this happening? See here, if you want to control arson related crime, you can see all the districts we have plotted. Tenderloin, Taraval, Southern District, Richmond Park, right? Then we have Bayview, which is the last district. See, out of all the districts, Bayview is the one which tops the list when it comes to arson related crime. I've not done any hi-fi sophisticated regression model, neural network, 2 hidden layers, 3 hidden layers, RBM model, nothing. This itself tells you so much, guys. Correct? You can build those algorithms, but find a way of presenting them in the form of charts and such things, because the person who's consuming this may not be a data scientist. Correct? Arson Bayview is the one. At what time is it mostly prominent? Let me go back. If you see here, what do you see? If you go back a few slides here, just see here, this is arson related crime. What did we say? Morning 5:30. So my answer is what? Morning 5:30, put police officers in Bayview if you want to control arson related crime. Very simple, very commonsensical thing. So this is what we can do. This is a good example of EDA, guys. Not because I have done it. Right? Compare this with assault. Do you see the profile itself changes? Now Bayview has, you see a very short bar. Now you see tenderloin and mission area basically increase. The bars are very, very high. So if you want to control assault related crime, focus on these two areas, namely tenderloin and mission. Getting my point is this. Now let's look at another set of data. Disorderly conduct. We saw 6 o'clock from people coming from bars and pubs. Maybe they're watching soccer, football. It's a big thing, and they beat up people. If their favorite team loses, Manchester United loses, they start stabbing. All this hooliganism, rowdyism starts. Right. So mainly it is happening in Bayview. Right. Look at drugs and narcotic. Bayview has gone silent. Drugs and narcotic mainly at 1 o'clock in the morning. We see. Where is it? Tenderloin is the district where you see mostly drug related offenses that are taking place. Simple bar chart, horizontal bar chart, right? Let's look at this forgery and counterfeiting. Southern district tops the list. Look at vandalism and such things. Southern area is again the one which is topping the list. Vandalism, everything we think that it is happening in developing country. In developed nations, what is happening, you can see for yourself. Right? Now you look at this. Is this understood, guys? Simple, no hi-fi. I've not even done testing of hypothesis because I wanted to keep it very simple and stupid. Right? So that I can just give you a perspective as to what we can do in EDA. Right? There's one more set of data that I took up. It is called as darknet. Do you all know what is darknet sites? Everybody? Darknet sites. Right? Yes, exactly. These are all basically hidden websites. They're all websites which are basically operating illegally outside the purview of law. Right? They are all operating sites. They are all banned websites. Right? But this is the place where you can buy all illegal items, drugs, malware. If you don't like your boss, you can order the assassination of your boss. You'll find the people. Right? There are all kinds of things. You can get crime, murder, what you want. You this thing, you know, other machine guns, stun guns, weapons, expensive weapons. All banned, illegal, contraband articles can be found in darknet websites. Okay, now this is one data set which I picked up, and this is the preview, right? There's a person called as David Skipper Everling. He's the person who wrote a Python code, and he went to these darknet websites, right? And he was able to pull out the code of cocaine dealers, people who sell drugs, right? And I'm not joking. Just a few months back in Kolkata, they arrested college-going students. They went to darknet sites. They had purchased drugs, and they are selling it to people from other colleges. It's something which is really happening, right? And if you look at Bollywood actor son, recently he was in news. Even he was getting cocaine and such things from darknet sites itself. Right? And if you pull this down, this very quickly comes up in another name. If you pull that down in another name, it comes. So this gentleman, from 1,440 cocaine dealers, basically, he has pulled out all the transaction details of drugs that are happening. Correct? So I just focused on this data. This data also must be there in the net here. Look at this. This data approximately consists of 1,400 cleaned and standardized product listings from Dream Markets cocaine category. So out of all the products, I mainly focus only on cocaine, right? So it was collected with web scraping. So he's written a code to scrape this information and text extraction techniques in July 2017, almost 4 or 5 years back. What are the features are there? So you can see here, product title is there. Shipping from to, from which place to which other place is he shipping, that is given. Quantity, how much of quantity are they basically shipping, that is there. Quality is also there. It is like Amazon for drugs, where you have rating, right? Product rating. This is high rating. The same way they give rating. That's why it has become so wide. It has become, then you have quality, BTC price, Bitcoin price. Correct? Then transaction done on Bitcoin, vendor details is there. Shipping details are also there. I'm just giving the link also. See here, when I looked at the data was like this. Real-time data, it is not my imagination. You can just see here grams. How much of grams is he selling? 1 gram, first fellow, right? Quality in Bitcoin prices, right? It's from 1 to 100. If the values are 90 and such things, quality is very high. Less than 90 means basically it is not good. Okay. Then you have BTC price, Bitcoin price. Correct? Bitcoin price is $0.02 or something. It is in dollars per gram. Then you have cost per gram. You have cost per gram pure. For pure cocaine, there is a different cost. Okay. Escrow account. What is escrow account? It's a hidden account whose details cannot be traced. You cannot trace this. In Mexico and all, people have, they have an empire. They've built an empire for themselves just through selling drugs and systems. Mexico is the place wherein entire US population they've spoiled thanks to Mexican people. Right? Next is basically vendor name. Look at the names here. Mr. Molly. Wow. Nice name, right? This is alias name. Obviously, he's not giving his real name. Old Amsterdam. You can almost imagine this is from Holland. Right? Then you have smooth criminal, cocaine UK. Right? Successful transaction. How many what is the transaction he has given? Successful transactions 90. So tomorrow, if you have vendor data also, you can by and large apply the same thing. That's what I'm saying. Right? Then you look at rating, right? It is from 1 to 5, 4.63. That is the rating, which means that his rating is good. You can buy from there. Okay. Next is where is he shipping from? NL means Netherlands, FR means France, GB means Great Britain. He's shipping from Netherlands, and where is he shipping to? EU means European Union. He's shipping to European Union. Maybe he's smart enough to ship to other places because he does not want to get caught. I don't know. Right? So this is the data that is given. Okay, so when I took this data, I just basically looked at top 20 buyers. See, 1,400 people are there. Possibly I can't study all 1,400. I focused my attention on only the what? Top 20. Do you see frequency of transactions here? Simple table function in your Python. Simple table, or you go to pivot table in Excel also you can do. Then you have the percentage of transactions. Then what I did is basically how do the suppliers compare to compare on cost? So all the vendors I took in the x-axis and the cost variable, which is a scale variable, I put in the y-axis. Do you see different box plots corresponding to different vendors? Everybody, correct? So when you look at this guy here, the best chemist, last guy, his cost is the highest. Can I say that? Because look at the average, the thick line. So the best chemist, when he's selling this cocaine and such things, he's the most expensive guy. Now look at this guy here, Coca-Cola FR. His is also on the higher side. But when you compare the best chemist with Go Fast team is also selling, but his cost on an average is almost half of that of the best chemist. So compare two people, the best chemist and Go Fast. We'll have more clarity. Simple box plot I've used. Performance as well as volatility. This is performance. The thick line at the center indicates the performance. What is the average cost? Can you see the box plot whiskers here? Right? Don't you think it is bigger? Which means that there is more volatility in the price when it comes to the best chemist. When you look at this chap here, the Go Fast team, the box itself is very short, which means that basically there is less price variation and such things when it comes to the Go Fast team. Making sense? Just scroll down, right? Source of shipment, right? Now all the vendors I'm plotting along the y-axis, but let me just focus on one example here. Let's just look at the best chemist. What is he doing? The best chemist, if you see here, mostly he's shipping from Great Britain. Source of shipment, from where is he shipping? Great Britain. Now, what is the destination of shipment you see here? Destination of shipment is worldwide. From Great Britain to worldwide. Let me go one step back. See here, guys, the best chemist is one thing. Go Fast team, you can see an orange colored bar. Orange corresponds to DE. DE means Germany, Deutsch. Correct? So this chap, he's shipping from Germany. Where is he shipping to? He's shipping to what? Germany and worldwide. So that is his transaction area. That's his business area. Simple bar graph, simple EDA, but you can understand so many insights here, right? Let me scroll down. Now look at this. When we compare two people, in the y-axis, I've taken all the scale variables like grams, quality, cost per gram, successful transactions, and I've got two sets of people: go fast team and the best chemist. Look at when it comes to grams, 45 grams is what he's he's selling. 45 grams is on the higher side. Compare it with best chemist, only 1 gram. Right? But when you look at the quality, 94 is the quality, guys. It's on the highest side. It is the highest. So when it comes to the best chemist, he is like the Ferrari or the Louis Philippe or the Van Hussein, right? Limited quantity, highest quality, right? Cost per gram is 0.04, which is understandable. And then the successful transactions that he has done is 980. Able to get it? Right? If you look at go fast team, look at the volume, 3,250, almost 3.5 times. It is the highest in terms of, it is the highest as compared to the others. 3,250 in terms of volume, go fast team is the one who is doing the highest. And look at the cost per gram, 0.02, which is almost half the cost of the best chemist. His rating is also okay, but not as good as the best chemist, right? So he's like the big bazaar. One is focusing on volume, the other one is focusing on value. Right? So profile one, what can we say about the profile of the best chemist? Very small shipment quantities, highest price and highest quality, highest price volatility, shipping from Great Britain, and he's shipping to European Union. This is the profile of one of the vendor. Compare it with the profile of the second guy here. I've also done decision tree. This is one of the algorithms, but I'll just not show you. I'll just skip this slide, right? When you look at Go Fast team, he's shipping what? Moderate quantities, low price, highest number of transactions, low price volatility, shipping from Germany to Germany, shipping worldwide as well as to Germany. Are you able to understand something, guys? How to do EDA? That EDA itself should basically send shockwaves. Send shockwaves in the sense basically what is actually happening. Then as a last step, basically you can build a algorithm. Just right, just to show tomorrow when you are doing an EDA, or maybe at the end of the day, if I give you an assignment, how you can basically fine tune the process of EDA. That's what I'm just trying to do. Can we just have a quick break for coffee and then come back? Okay.
So this is like the profile summary, right? At
Yes.
the end of the EDF, you will this.
Yes. Yes. Okay, shall we break for coffee and can we come back, guys?
Sure.
Sure.
Guys, are you all back?
We are there.
Yes, Amar Kaushik. Guys, I'm opening up Jupyter, guys. Please open up Jupyter, right? We just finish off a couple of tests, then we just move on to linear regression. 2 tests we just finish off. We are done. What all we are done?
No, I wanted to ask one question regarding that crime database.
Please ask, please.
So, by then you had moved on to the next one, darknet. See,
Okay.
in your crime database, the data that you showed,
Yes.
showed like how the crime was solved or like what is the status. But more than that, like the motivation or the intention would have helped, right? Because our intention of collecting the data is to prevent the crime.
Correct.
But how it got solved, whether it is solved or not, is lesser useful information compared to the motivation itself.
Motivation to the crime, yes. You're right. The motivation to commit the crime is also important. I don't think we had that variable like motivation to commit crime.
Okay.
They didn't collect it, but ideally speaking, what you're saying makes sense because if we would have known the motive, then we can basically prevent that thing. And many of the cases, I have not shown the entire slide here. I've just shown a snapshot of the slides here. One small slide also I had sort of prepared wherein I had calculated the percentage of resolved issues. And many of the issues there are still unresolved.
Okay.
The 50% plus cases are really not resolved, right? But anyway. Can you see my Jupyter notebook, guys? Okay. So I want to sort of tell you about one important test, which is called as one-way analysis of variance, guys. It is called as one-way analysis of variance. Okay. Any idea what is one-way analysis of variance? One-way ANOVA. Right. So this is the topic. We'll just quickly try to finish it off. Control Enter. B. Let's import the necessary libraries. Right. I'll again fall back to all these things. It's good that we just ignore this. So stats models.formula.api as SMF stats models. Okay. Yes, when we did this A/B testing and such things, did you notice any problem with A/B testing or independent sample t-test? Any problem did you notice?
So A/B testing, as an example, we did not see Mithun.
Yes.
We saw only the first and the third.
Yes, we saw the first and third, but in terms of concept, A/B testing, when I say you can handle only 2 groups, correct? At a time, you can handle 2 groups, A versus B. But in a real-time scenario, you may have multiple variants. You may have 3 variants or 5 variants. So when you have more than 2 groups, you can't use A/B testing. Right? For example, it's like comparing your child's performance with your neighbor's performance, neighbor's child's performance, as well as your relative's child's performance. 3 groups are there. So when you want to compare among these three groups, your A/B testing does not help you. Therefore, we have a very, very powerful test which is called as one-way ANOVA. One-way analysis of variance is used when you have got three or more than three groups. When you have got three groups or more than three groups. Correct? So we all are familiar with this breaks data set, everybody? Can I help you?
Stats model.
It is stats models.
Stats.
Working? No.
Sir, I'm seeing a screen at the import library still.
Yes, yes, I'm there only. I have not moved anywhere. Got it? What is the mistake? Package? Yes, you all have breaks data set. Everybody has breaks data set. Can you see this data set, everybody?
Yeah.
LMS must be
We
there.
have it from the last week's.
Yes, we
yeah.
can use the same thing. Okay.
Yeah, we have.
Okay, you have breaks data set, correct? Now, developing the same problem, when you have more than two groups, correct? We can compare the mean performance across these more than three groups, correct? So when you look at the variable machine, and I hope you can see my Excel sheet, how many groups are there here?
8.
8 groups are there, right? So for these 8 groups, is there a significant difference in the average display diameter? Not 1 or 2, we have 8 groups now, which is greater than 2. Therefore, we can use this ANOVA here, right? Here we don't use independent sample t-test because 8 is greater than 2, correct? So let me just close this. Okay, let me just come back to the code. I was here. Let's proceed with ANOVA. So this is ANOVA. See this SMF, which is nothing but statsmodels.formula.api.ols. OLS stands for ordinary least squares. So your dependent variable, which is break tilde machine, right? Comma data is equal to DF. So this will definitely give us an error because we don't have this df object. So before executing this, would like to import the data set breaks. Right. So let me just quickly import the data set and then execute this command. So where is my breaks data set? Okay, import breaks data set. So I first imported the data set. Now we can run the ANOVA output. Right. See, is it okay? Please.
Are we expect to get different results here?
Sorry.
Will I be getting a different result than yours?
Ideally speaking, unless you made changes in the file in your system, you should not get different results.
Okay.
Where is the difference? Is there any specific statistic where there is a difference?
So for me, the machine itself shows as DF as 1.0 rather than 7.0.
Okay. Can you share your screen, please?
Okay. I just copy paste.
So for me also, it's like Ganesh's. It's DF is 1.0.
Okay, just show me the thing. It can't be 1.0, ideally speaking. Okay, degrees of freedom is 1.0, residual. Okay, can you show me the source file, breaks?
Just a copy paste from the previous weeks.
Okay, now let's please go to the code. Jupyter Notebook. Breaks.csv01 128 rows report.
Can you confirm on the number of rows in yours?
In my case,
And also the last value, the first and the last value.
128 rows, 2 columns.
Okay. And the value for machine 8, the last one, row number 127, is it 321?
321.996.
Okay.
So, okay, 1 second. Okay. Are you able to see this?
I'll unshare my screen.
Okay, I'm sharing my screen. Can you see my screen, please? You know
No.
why?
Yes,
Can you see my screen?
yes,
Yeah.
sir.
You know, one thing is basically, see, you had run till here, right?
Correct.
And after this, there's one more line of code wherein you can treat the first column as a string.
Okay.
That categorical variable, I'm just calling it as a string. You can treat it as numeric also, not a problem. Right? df.machine.asType. I'm changing the data type to string now. This is not mandatory. I've just tried this option. It is not mandatory. If it is numeric, you can leave it as numeric itself. But here, machine 1, machine 2, I was under the impression that it is mostly, I will consider this as string. And therefore,
Okay.
in my
So
case, it is giving.
we don't need the second statement below that df while you are the
This
second.
one, this is optional. No, this is optional. Don't have to give this mandatory. No need.
Oh.
I may have been trying many things, so I was just experimenting. This is okay.
Okay. Okay. Got it.
The main thing is just remember this smf.ols break tilde machine. So now if you see here, it is 7.0, which is.
Can you stay there for a minute? I'll just type that.
Sorry.
That string conversion.
Okay, sure. I'm just
Mm-hmm.
changing the data type by specifying dot as type.
Okay, now done. Yes.
Okay. Everybody's done. Same page.
Yes, sir. As a particular.
Okay. So here there are some numbers. You don't need to keep everything in mind, but I'll just tell you what is what here, right? I'm very high level. Correct. Do you see this degrees of freedom? You see, DF basically stands for degrees of freedom. Theoretically, it has meaning, but here when we are doing from practical perspective, it does not have much meaning. So 7 you are getting because there are 8 breaks, 8 minus 1. That is the formula that is used here. I look at this sum of squares. Sum of squares is how do you evaluate the change in the disk break diameters? Right. So the variability is captured as sum of squares. So you have 0.004. If you divide that by 7, you should be approximately getting 0.000618, which is the mean square. Nobody expects you to know this, but I'm just telling you out of curiosity. Similarly, 0.01 divided by its degrees of freedom should give you the mean squares. And the ratio of the mean square will generate the F statistic. And the p value or the probability value is generated. Probability value is produced for F. If you see the p value, it is 5.07 into 10 to the power of minus 7. 5 point something into 10 to the power of minus 7. It is 0.5 5 zeros, sorry, 7 zeros, because it is 10 power minus 7, 0.7 zeros and then some number. Is this less than 0.05 or greater than 0.05? It is clearly less. So what is the decision criteria that we will be using? If it is less than 0.05, then we reject or null and conclude that there is a significant difference in the average disc brake diameter produced by these machines. There is a significant difference. So each of these machines are producing an average disc brake diameter which are varying. Now, which one is varying the most? Which one is varying less? To understand this, numbers may not always help me. So what I will do is to further process this, I will just put this as a box plot. Okay. Right. I'm just going back to Seaborn. So we need to install Seaborn library. So
sir, can you just paste the text in the chat box also?
second, this text you want?
Yeah, this one and that above one and above one.
For ANOVA?
Yeah, just above. It's just
This one?
yeah, this one.
I'm just pasting. So chat is it? The first code you wanted. And the second code you wanted is about this box plot, right?
Thank you.
Importing the Seaborn library and then import PLT is not defined because we need matplotlib. Correct. Some of the properties of matplotlib, plt.xlab and such things. So if you want, we can just do this import matplotlib dot pyplot as plt. No module named mat. There is a spelling mistake here. Okay.
Sir, when you call the smf.ols, you had introduced a tilde symbol between break and machine. Uh, Does it signify any operation there?
This one data.
Break tilde machine.
Yes.
Well, you're calling it.
Yes. See, what's happening here is that the dependent variable or the scale variable will be to the left side of the tilde symbol. And to the right side of the tilde symbol, you will be specifying that variable which has multiple categories.
Okay.
So what it is actually doing is that within this variable of break, right, the variable break is broken down by 8 different categories. And for 8 different machines, it is finding out whether the average disk break diameter is the same or not. So if you want the general syntax of this, it is simply SMF dot OLS, right? You can give any scale variable broken down by a categorical variable. To put this on within tilde symbol. This should be the general syntax. For example, you can just say amount of money spent, which is a scale variable broken down by different stores. Stores is the categorical variable. So this would be the general syntax of ANOVA.
Okay.
So I'll just put this in a different line altogether so that I don't confuse you. So I can just call this as general syntax. So in the Excel, when you open up breaks, what is it? In Excel, when you open up breaks, there are 2 columns that you can see, correct? In Excel, the first variable is categorical and the second variable is scale. For the first variable, there is no point, taking mean. For the second variable, which is a scale variable, we have to take the mean. So what we are doing in this ANOVA is that the scale variable should be specified first. In my case, what is the scale variable? The scale variable is break, right? The second variable, which is categorical, is machine, right? So that categorical variable is followed after the tilde symbol. Is it clear?
Makes sense, sir. Yeah, clear. Yes.
Yes. So, okay, I hope you're through with the box plot, everybody. Okay, see here, there are 8 sets of machines which I'm plotting along the x-axis, and you can look at the variation in the y-axis. Just see here, around 0.00 by and large, if you consider this as the benchmark, right? So if you consider this as the benchmark, first set of machines, it is more or less concentrated around 0. But look at the second guy, it is almost varying the highest. Average disc break diameter is almost highest. I don't know, is because of old machine, it needs repair, we have to change the spare parts, I don't know. But second is basically very curious. Look at the third one, it is almost process compliant, I would say. Fourth one, very curious, it is showing signs of deviant behavior because it is not exactly 0. It is also not very, very different, but slightly it is behaving weirdly. Look at the fifth one again. It is OK, I would say. First set of machines, third, fifth is OK, sixth is OK, seventh is very curious, eighth is also very curious. But the real problem, source of problem seems to be second set of machines. Are we clear with this? ANOVA? Is ANOVA clear, guys? If ANOVA is clear, shall I make a move on?
So is the inference the second one is?
Yeah, the second one needs to be investigated further.
Oh, okay.
Second one looks, process non-compliant. So we need to investigate the second set of machines further. As far as the first set of machines are concerned, you can be happy that there is not much of deviation and such things. Third set of machines, not much of a problem. And even the fifth set of machine, not much of a problem. Fifth, sixth are also OK, right? 7, 8, right? 3 are curious. I'm using the word curious because when you look at 7, 7 is slightly on the higher side, 8 is slightly on the lower side. But the second one, you can be very, very certain that there is something happening there. I hope this is clear, right, everybody? Right, one sample t-test we have done, right, everybody? We have done one sample t-test. We have done ANOVA. Now, let's make a move on. Now, just as we have one-way ANOVA, what I would like to do is basically, I would like to introduce you to what is called as two-way ANOVA. This is called as two-way ANOVA. Right, we did one-way ANOVA. One-way ANOVA has one categorical variable, right? So in the breaks data set, how many categorical variables I have? I have only one categorical variable. I don't have 2 or 3 categorical variables, correct? So I can't show you two-way ANOVA in one data set itself, right? So it's a different problem altogether. I need a data set which has 2 categorical variables, correct? So in your data set, there must be a file which is called as grocery. Grocery. Last time itself, I had sort of shared with you grocery file. Yes, 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 yes. We will be working on that file for two-way ANOVA. Right. First, let's quickly do a EDA for two-way ANOVA. This is exploratory data analysis for two-way ANOVA. PD dot pivot underscore table. Here I'm just doing an exploratory data analysis, right? Oh, but I have not imported the data set, correct? So I need to import the data set. So before running a EDA, let me quickly import this data set, which is called as grocery underscore 1 month dot sap, right? So let's just import this, please. I'll just say import file. Right. One way, the number 1 there is for one categorical variable. If you're comparing based on one categorical variable, use one-way ANOVA. If you have two categorical variables, it is called as two-way ANOVA. If you have three categorical variables, it is called as three-way ANOVA. Like this, you can have n number of variables, in which case it is called as n-way ANOVA. Right? All these things are part of what is called as general linear models. It's all part of what is called as general linear models. Are you comparing based on one categorical variable or two categorical variables or three categorical variables? One-way ANOVA, two-way ANOVA, and such things are widely used in the manufacturing sector. Okay. This pivot table we have already done, wherein I'm specifying the data set name. Values will be followed by the scale variable. Put a comma and say index. Index, if you recall, is where you're specifying the row variable. Row is a list here. It is not one variable, right? So since it's a list, I'm using square bracket, and within the square bracket, I'm specifying two variables, gender and style. I'm specifying two variables, gender and style. Yes. Scroll down. Just looking down. There's nothing down. Up. Okay. Okay. It's okay. One way, no, one category. We can have any number of categories. Guys, can you see this data set, everybody? Grocery underscore 1 month, correct? So amount of money spent, look at this data set. You have store ID, healthy food, size of the store, organization, customer ID, gender, shopping for, right? Vegetarian or not, what's his shopping style, usage of coupon, amount of money spent, right? And 3 other variables which I'll not be using. I'll keep it very simple here. I'll just remove all the unwanted columns and only keep useful variables here, right? What do you have? You have the variable gender. Delete this, everything I'm going to delete it so that it's very easy for you to visualize. Correct? Imagine that I have this, only these. Correct? Are you able to see this, guys? Everybody? Right? So this is what we are trying to find out. The first variable, which is gender, which is male or female, right? Which I will be sort of coding, which I'll be sort of coloring in blue. That is your first categorical variable. Do you agree? Males or female? The second one, shopping style. There are 3 types of shopping style: bi-weekly, weekly, and whatever. Right? The third group is there, people who come often. This is your second categorical variable. The last variable which we are talking about is not your scale variable. This is your sorry, it is not your categorical variable. It is your scale variable. Now, since we have got 2 categorical variables, we'll be running a 2-way ANOVA. In breaks, I did not have the second categorical variable. I had only 1. Right? So there I could not show this, but in this grocery underscore 1 month, we will be looking at 2-way ANOVA. So simple pd.table, pivot table we can do as the EDA. Next, we'll go ahead and do 2-way ANOVA. So, okay, let's quickly run out 2-way ANOVA. So we can visualize this as well. If we can just visualize this. I'll just copy paste this in group so that you can just paste this code. So it is giving me a small error which says NP is not there. So simply say import numpy as NP. Correct? We are using np.mean here. So this is what you'll be getting.
Can you also flash that table, pivot table statement once?
Yes, yes. Can you see here? Gender, females and males, there are 2 groups. Females, there are 3 groups: bi-weekly, often, and weekly. From among the female category, the biggest spenders seem to be people who come often because they're spending $405. From the male category, you can see the biggest spenders would be male weekly customers. Male weekly customers. The lowest spenders would be basically female bi-weekly customers. I'm using a bar plot here and not a box plot. Reason being, box plot would give you the median, not the mean. Here, when we are talking about ANOVA, we are looking at a mean comparison, not necessarily a median based comparison. Correct. So this is what it is telling you. Look at this bi-weekly, you have two bars. Blue one corresponds to males, orange corresponds to female. From among the bi-weekly customers, the blue one outperforms orange, which means men tend to outbuy women. Right? The amount of money that men spend is higher. Same thing with weekly customers, but when it comes to often they are neck and neck. Are you good with this? Right. Let's move on to the code part of it. OLS is not OLS. So please observe this. This is amount of money spent, correct? Do you see this?
Sir, you are not audible.
Yes, I'm not speaking anything.
Okay.
I'm just waiting for you. If you're through with this, yes. Just tell me if you're through with this. Are you clear with this case, everybody? See here, amount. This is the dependent variable, which is a scale variable, broken down by the first categorical variable, second categorical variable. We are putting a plus, and then we are saying style colon gender, which means what? Any idea? Exactly. So which means basically, if you are including only style, that is the first categorical variable, which is called as main effect, only one variable. If you're including the second variable, that is gender, that is only the second categorical variable. But if I want to check the joint effect of both the variables style and gender, I'll have to put style colon gender. Right? In the case of one way ANOVA, there is no question of having a colon because I had only one variable. Correct? So this is where we are putting style colon gender and specifying the data. And we are saying sm.stats.anova, comma lm model type is equal to 2. Whenever you are specifying this interaction effect, it is better to use type equals 2. Whenever you're specifying interaction effect. So this interaction effect basically is as good as what is called as feature generation. We are creating a new variable. This is the third variable in the data set. Effectively, you have two categorical variables. We have combined them and we have made this as the third categorical variable. So what does this mean? Style, if you look at the p-value, it is significant. Right? So there is a significant difference in the amount of money spent by the three different shopping styles. Correct? Let's look at gender. Again, the p-value is less than 0.05, which means that there is a significant difference in the amount of money spent between males and females. Now, when I look at both style and gender, which is the interaction effect, look at the p-value, it is less than 0.05, indicating that interaction effect of style and gender, shopping style and gender, is also significant. It is also having a significant impact on the amount of money spent.
So if I look at the data set,
Yes.
the style itself is a combined value. It has a combination of bi-weekly in bulk or a weekly similar items.
Yes. See, style when you say bi-weekly, which means people who buy twice a week, correct?
Mm-hmm.
Are you able to see this Excel sheet?
Yeah, we are seeing that, yes.
Yes. So this bi-weekly means twice a week. Weekly means whatever, I think every week they purchase, and often means people who come often. So when I am talking about interaction effect, what is Python doing at the backend? It is generating a new variable. I'm just telling you, I'm creating a new variable so that I can show you this. And that new variable would look something like this. Though we are not displaying this, it is gender style. So this is a new variable that it computes. How will this look like? So males who are bi-weekly customers, they will be marked as one category. They are group 1. Right? So males who are bi-weekly, again, you can just extrapolate the same logic, which is group 1. Now, males who shop weekly, they will be considered as group 2. They're considered as group 2 altogether, separate group. Now, similarly, males who shop often, if I just scroll down, males who shop often, where is it? Okay, 27th case, you just observe this particular case. So this is a case wherein you have males who shop often. So they will be considered as group 3. So Python will generate a new variable group 1, group 2, group 3. Similarly, if you look here, female who shop weekly, they will be considered as group 4. And then females who shop weekly, again, group 4. Let's look at female who shop often. This is considered as group 5. Females who shop weekly, yes, this is considered as group 6. So it is generating a new column when we say interaction effect. And then we are checking whether this column is having an impact on the dependent variable or not. So though it is not displaying, so this is the meaning of interaction effect. It is 2 categories versus 3, which means group 1, group 2, group 3, group 4, group 5, group 6. So that is what we mean when we say interaction effect. So if you have 3, you can create actually 2 interaction variables. If you have 3 categorical variables, first categorical variable, second categorical variable, and the third categorical variable, interaction of first 2 variables can you create? Do you agree? Interaction of the first and the third can you create? Interaction of the second and the third can you create? Interaction of all the 3 can you create? So effectively you can create 4 new variables. So this is what is called as feature generation. Feature generation. Please understand from a data set point of view, sometimes you have too many features. So you will reduce. Your problem might be data reduction, right? Sometimes you have few variables. From few variables, how do you generate more variables? Interactions. Work on the interactions. So if you can have 3 categorical variables, I'm just giving an example. If you have 3 categorical variables, first variable and second variable, you can find the interaction. First and third variable, you can find the interaction. You can find the interaction between second and third, and then you can find out the joint effect of all the 3 variables. So effectively, you will have 4 variables, 4 new variables you are generating, which is actually, it has a different property as compared to the original variables, though it is derived from the original variables. So if you are looking at only one categorical variable, it is called as the main effect. Main effect. If you're looking at 2 variables, it is called as what? Joint effect or interaction effect. Right? Suppose if there is an elephant and I'm fighting alone, right? I'm fighting alone. So that is joint effect of Mithun on this elephant, right? Let us say I'm not alone to fight this elephant. I am also taking the help of Ajin, right? So Ajin is the second person. So he's fighting alone. He's maybe trying to strike at its belly. I'm trying to strike at its trunk. So that is his main effect. Now both of us combine forces and then we try to kill the elephant. So this is the joint effect. Main effect is different, joint effect is different. In the case of ANOVA, main effect and joint effect, both of them you need to look after. Whether you want to look after, that's your choice. Some people just say I want to look at the main effect, but some other times you may have to look at the joint effect along with the main effect. Does this make sense, Ganesh?
Yes, but when you did the plus here, it means like we are taking them into together. That's what the meaning is, right? When you
I'll open up this. See, when I'm can you see my code?
Yeah.
This is the first variable, plus this is the second variable, main effect. Plus, how do I tell ANOVA that I'm also looking for the interaction effect? So I'm saying style colon gender, which means that Python will understand saying that, OK, this fellow is trying to look after the interaction effect between style and gender. So this is the third effect that it will give me. Now, let us say I don't take this into account. Let's say I'm just deleting it just for the sake of clarity, right? Just to make you understand, right? So let us say I will just choose style plus gender. Earlier, how much I got? I got style, gender, and the interaction effect. Now, when I execute this, it will just give me the main effect of style and gender, ignoring the interaction.
Okay.
So this is optional. Sir, should I always specify this? No, it depends upon your business understanding. If you feel that, yes, men who come bi-weekly customers tend to be more profitable as compared to females who come bi-weekly customers. Men who come twice a week and females who come twice a week. If you actually think, men who come twice a week, maybe they're bachelors or whatever, I don't know. They have maybe or they're working professionals. Twice a week, Saturday and Sunday, they come. So they buy in bulk. So maybe their purchase amount is higher. If you look at females who come twice a week, maybe they're college going students. Maybe the fancy items, decorative items, they buy and go. So there's a difference in their profile itself. If you feel that you have to account for this also, then the question of interaction comes into picture. Is it mandatory that you should always look interaction? The answer is no. It is entirely business driven. It is entirely
So
business.
why not we just take the interaction only? Why need we put style plus gender plus style colon gender?
Yes,
Why not?
because when I say style, there are three groups within style, correct? Bi-weekly customers, weekly customers, and within customers, correct?
Yeah.
Bi-weekly, weekly, and often customers. Now there could be a
Okay.
difference among these three groups also.
Okay.
Within the variable style also there could be difference. Within the variable gender also there could be a difference. Within the interaction of these two variables also there could be a difference. So I am just showing what all possibilities are there with just two variables. See, now that we have run this for style, we are getting p values less than 0.05. So we are in a good position to say, yes, bi-weekly customers, weekly customers, and often customers, their spending behavior itself is different. Why? Because the p value is less than 0.05. Now, let us say I don't take into account the style and gender as Ganesh is saying, correct? And I'm just interested in the interaction effect. Now, this is telling me that the interaction effect is strong, but do I know that the main effect is strong or not? It is silent on that. It is silent because I've not specified that. Ganesh, am I making sense?
Trying to digest.
No.
Yeah.
Okay.
Maybe a similar example when we try, I may understand. But for now, whatever you explained, I'm able to.
Yes.
Be able to get it. Yes.
Okay. Okay, let us just try this with one variable, guys. Let's just try this with style. Correct. Now, what does this tell you actually? If you're actually looking at only the variable style, there is not much of a difference if you just look at shopping style only, correct? But is amount of money spent when I look at, it is not driven by only one variable, correct? There could be second variable. So to if I want to look at the second variable, what will I put? I will put gender. Let me just look at this variable. Style is having an impact. Gender of a person is also having an impact, right? Gender is having an impact means what? Whether you're a male or a female, that aspect, that fact matters when you spend, because men may tend to spend bigger amount and females may tend to spend lesser amount. So gender is having an impact. Earlier we said that style is having an impact. Style is having an impact means what? Within style there are three groups. Which are these three groups? Bi-weekly customers, weekly customers, and people who buy often. So these three variables, these three groups have a different spending behavior. Now, I want to one more additional piece of information, which is I want to find out the interaction effect between both the variables. So it is style colon, where is colon? Gender. Now you can see style colon gender. This is also turning out to be impact. Men who shop bi-weekly, females who shop bi-weekly. Very different. Men who shop weekly and female who shop weekly, their behavior is also different. At the end of the day, what do I understand? What do I understand is just go to the pivot table for one moment. Please look at the pivot table, right? Which is the biggest number in this? 440, can I say 440 is the largest number, which corresponds to whom? Male customers who come weekly. So the most profitable customers who come to my shop are male weekly customers. So if I have to market expensive products, to whom should I approach? Should I approach women? No, the biggest amount of money that is spent is male weekly customers. So I would rather approach them because the highest on an average their spend is $440. Let us say I want to find out which is the cheapest spend. Who is that segment? Which is that segment which is spending the lowest? See, this is 440, 407 and 400. Look at the females 343, 405 and 367. Let me highlight this. So female weekly customers tend to be the least profitable. Male weekly customers tend to be the most profitable. Female weekly customers tend to be the least profitable. So female weekly is 361, right? So my apologies, female bi-weekly, because they're spending 343, their number is lesser. So female bi-weekly customers, they tend to be least profitable in the entire group in the entire segment. Ganesh, is this okay?
Yes, sir. Understanding. Yes.
Okay.
Sir, this is Nidhi. One question.
Yes, please. Yes.
So
Please.
when you were doing just on like one category, categorical variable style, the value was coming something like 3.9.
You're right.
And then like if you are using like three categorical variable, then why the sum squared for style is changing?
You're talking about the p-value, right?
Sum squared, the first one value.
Yes, this sum of squares is changing, correct?
Yeah, if we are introducing like three categorical variable, then the values is changing. If we are just putting style,
You're
then it
absolutely
comes
right.
3.9.
It's
Why
a good,
it is?
yeah, it is a good observation because what we say is basically this is a one variable model. The formula for one variable, when you include only one variable, namely style, that formula is different from when you include two-factor model. When you're including two factors, the formula will be different. Finally, when you include the interaction effect also, the formula will be slightly different. Because of that variation in the formula, the final answer that you're getting will also change. But for all practical purposes, this sum of squares, you don't need to break your head so much. Worry about the p-value because that is the one which will help you make a business decision, not the sum of squares.
Even the p value is getting impacted if we are
Yes.
into
Correct. See, if you are taking comprehensively all the variables in the data set, it is a comprehensive model. So ideally speaking, look at a comprehensive model rather than just one variable, I would suggest. So you can finally go by this model because this is the comprehensive model which takes into account the joint effect as well as the main effect. So if you are taking only the style variable, it is an incomplete model and it does not reveal the complete picture. I took a single variable and built the model because I was just trying to illustrate to Ganesh what is main effect and what is joint effect. But for all practical purposes, it would be good if you take into account all the comprehensive possibilities in the data set, which means take into account the joint effect as well as the main effect. So this is a true picture and this is the final model that you can go by. Is that okay, Nidhi?
I'm not clear yet because like I was thinking this will be like independent style and gender, and there is new variable we are introducing. So that the new one only will be the different thing, but the independent should come as is.
No, just think of it like this. Let's say, let us say, I am just trying to model price of a product. Price is my dependent variable. OK. Price of a product I'm trying to model, and I am taking only one variable into effect, which is customer's gender. Customer's gender itself might not influence a variable like price or sales of a particular product. So when I'm using only one variable, namely gender, that variable might turn out to be insignificant. Now let me look at it from another perspective. Let me look at the second scenario wherein I'm taking not just the main effect, but also the interaction effect, meaning I'm looking at gender. I'm also looking at what is their individual income levels. When I'm taking individual income as well as gender, right? So this is a different model altogether. So in this case, the two-factor model is able to is more comprehensive than the first model. And therefore, the two-factor model will have certain different results as compared to the first model. First, you can't basically, all that I'm trying to say is that we can't oversimplify and explain the variability of amount of money spent merely by looking at style. We will get a slightly misleading picture. If you take into account only gender, it is less comprehensive, but it is better. But if you include all the three combinations, then you're using a full factor model whose formula is different, and therefore the results will also be different. Is there still a confusion with this, guys? I'll give you one more example in the second half. Maybe
my question was like when we are introducing something, the real one should not change. This was my understanding.
Please come again.
When we are introducing new variable, the combined variable. So the independent should not change. I mean, if we are using just like writing the code only with the one variable, style or gender, so whatever data comes, that same data should come when we are introducing a new variable also. This was my understanding.
So what happens is that Nidhi, there is something called as confounding effect. I don't know whether you've heard of this. There is something called as confounding effect, which means that the model behaves in one way when you have one variable, but in the presence of a different variable, the original variable, its behavior will change. So this is why we say this is called as confounding variable. Confounding variable is like, if you have one factor, it may have a big impact, or it may not have any impact at all. But if I include a second variable, in the presence of the second variable, the first variable's behavior might change. It will not be the same as, if I include two variables also, the original variable will behave the same. Three variables also, it will behave the same. It might not be the same. For example, let's just go back to one. I'm just thinking if I could give you an example of. Okay, let's just hear me out. Let's say we're talking about price of price. Let's say we are talking about sales and price of, let's say, vehicles. Sales and price, right? So usually what do we expect? Sales and price will have a negative impact. Can I say that? Which means if price increases, sales will go down.
Yeah, correct.
Correct. Usually this is the expected. There could be some, right? Here you're looking at only one variable only, that is price and sales. When I say one variable, price is the independent variable. Price is having a certain impact on the dependent variable. Now, not just price. Now let us say I'm giving you amazing features in the vehicle. I'm giving you very good features in the vehicle. So the original variable its behavior might change the moment I take into account other factors on the variable sales. So individually, when you look at it, certain signs and such things might be in a particular way. It could be positive or negative. But the moment you take other variables, additional variables, in the presence of other variables, this variable and its behavior will, and sometimes it will change. That's what I'm saying. I'll give you one more example, because after lunch we have to sort of build a linear regression model. There again, you will see individually, you will see that some of the variables will have a negative impact. But collectively, in the presence of other variables, when you study its behavior, its impact itself will change, which means that its magnitude will change, its sign will also change on the final model.
I understood, like whenever we are using more than one variable, it is like taking into consideration. Somewhere it is taking into consideration. I was not expecting. I mean,
you are not,
as per my understanding, I was not expecting.
Yeah, okay. So that's the reason there is in statistics and such things, we always say confounding variable, right? confounding variable. So if you are only taking into account X on Y, it may have a certain effect. So we say basically you are trying to say the impact of X on Y is positive or it is strong. But have you also taken into account other factors? When you take into account other factors, the original sign, magnitude, everything might change for the original variable. It may not be the same. That is what I'm trying to tell you.
Yeah, understood.
Right. Yeah, anyway, I mean, don't worry, even if you sort of have some doubts, because in the second session, we will be building a linear regression model. There I will sort of show you I'll give you better examples so that this point becomes a lot clearer. But the main point here is basically, guys, that in the case of one-way ANOVA, all that I wanted to say is that you have one categorical variable. In the case of two-way ANOVA, you have two categorical variables. You should also factor in. You can factor in if you want. It's your choice. If you want, you can include the interaction effect of both these variables. That is the main sum and substance of what I was trying to convey so far.
Sir, what was the meaning of F values?
What was the meaning of?
In the table below, along with the P values, there are F values also. Yes.
So you're asking me what is the meaning of F, is it?
Yes.
Yes, a very simple one-line answer I'll give you. In the last class, we spoke about T statistic. Do you remember?
Yes.
So T is a statistic which is mainly used to compare the means. F is a statistic which is mainly used to compare variation. So when we are talking about analysis of variance and such things, F statistic comes into picture. Remember, F is just a notation which is used to compare variances. The notation T is used to compare for means. If you remember that one sentence, that is good enough.
No, I get it that it's telling that the variance is 4 times. Right, but then, I mean,
what is there any?
Is there any interaction also with the, suppose that this time the F values would have come less than 1. In that case, how will you interpret this? And if it's 4 or 50 or 1000, how will you interpret this?
Good question. See, F can be 1 million or 0 or 5 or 500. I can't make any decision based on the F value. I can make a decision based on the probability of F. This is the column which makes most sense, which is basically look at whether this number P value is less than 0.05 or whether it is greater than 0.05. If it is less, we say that that particular variable has an impact. If it is greater, we'll say that it has no impact. That's the reason why I say when you look at sum of squares, degrees of freedom and F statistic, I can't make any conclusion or judgment based on these numbers because they are just intermediate steps. The final and the most important step here is the P value. That is what will tell me whether a particular variable style or gender or the interaction between style and gender is having an impact on amount of money spent or not. It is the probability of F value that is the hero of this analysis, and decisions can be made based on F statistic. You can in fact delete all these things. It will not make one single difference to the final conclusion because the final conclusion is on the basis of the probability value or the P value that you are seeing here in the last column. So in the last class also, if you see, we got correlation value, we got chi-square value, we got T statistic value, right? But I did not make a decision based on the statistical values because the statistical values tell me nothing much. We made a decision based on the P value or the probability value. We can always and we should always make a decision based on the P value because I told you that thumb rules. Look at the statistical thumb rules, right? I gave you several examples saying that if a student gets 80 plus distinction, right? Let's say 100 plus is greater than fever and such things. The same way, in the case of statistics, if the p-value is less than 0.05, the variable style is having a great effect on the dependent variable. If it is greater than 0.05, it means that that particular variable does not have any impact. So thumb rule, we are going by the thumb rule by when we are comparing it with 0.05.
If I have to represent the interaction, I mean the F ratio for style and gender interaction, what will the numerator of the equation?
What will be the numerator?
Yes.
Okay, so we will have to now go to the formula, which will be very complicated. I think I'll only confuse you further because the moment I say style versus gender, we will have to look at the formula. If you want, I can just show the formula.
Please just show me, because really I am interested in knowing that is really the variance 4 times or above 42 times bigger than the variance on the denominator side. In that case, it is a highly spread kind of.
No. Fraction effect. I'll just show you the computation with numbers. It will be a lot easier. Interaction effect. If there's a number, I think it'll be a lot easier for us to follow. So the formula and the numbers. Okay. Just give me one moment.
Yeah.
Okay.
Sir, you can show it to me after your lunch also, but the main idea was I really want to read the output of those tables.
Sure.
That it generates. I mean, if we are running some code and it's generating some output,
yes,
I think that each and everything should have a meaning. I mean, we do not take into account, that's a different thing, but I really wanted to know how to read this table properly. So that was the idea of asking.
Definitely. Okay, give me some time. I'll just find out a suitable example and share with you.
Yes, sir, that will be good.
Sure. Okay. Sure. Shall we break for lunch and come back?
Yes.
Thank you.
So what time will you be back?
That's 1:10. By 2:10, shall we be back?
Okay. Can you please send your the Jupyter notebook meanwhile?
Jupyter notebook. Okay, fine. Yeah, I'll send it.
Thank you.